vendor as well. So
Great.
Eric, the floor is yours.
Hey, thanks, Victor. This is going to be an awesome conversation today. And I'm going to start out with just a few, kind of bold statements as I get into a little bit of the presentation. But the goal is to have a conversation, and I hope we get into the weeds a little bit on this. And I'm certain with this group of panelists and this audience, we're going to have a great time. So let's get rolling. And I'm going to make this happen as quickly as I can. There we go. All right. So I'm Erik Peterson. I'm the CTO and founder of CloudZero. And I want to talk about this idea that a good friend of mine, who's the CEO over at Momento, really pushed me to start talking about more. We were sitting down to breakfast one day and we were catching up. And I said, I've been collecting in this shoebox, this digital shoebox of mine, $1 million lines of code. And he thought this was the craziest idea I ever heard. He's like, what are you talking about, $1 million lines of code? And I said, well, every time I've had the opportunity to work with customers on helping them get their arms around what they're spending in the cloud, I always kind of try to figure out, well, what was the root cause of some of these really big, challenging items? And a lot of times it comes down to very simple, small things, and in many cases, a single line of code. And so I started collecting those, and it put me down this path of how powerful the engineer is in this conversation around FinOps. So that's what we're going to get into real detail here. I've been building on the cloud for a long time, but honestly, the only thing that matters in the world of the cloud is your ability to learn, because everything that we know today is going to be brand new in the next 6 months. It is constantly changing. I think there are no experts. You have to stay humble. So it starts with this statement. I think that we're all in some way, whether we know it or not, surfing this wave, this world that we live in, where every engineering decision is a buying decision. I write a line of code, I'm spending money. I deploy some infrastructure, I write some Terraform, I'm spending some money. I'm making a purchasing decision. In fact, there's more, strangely enough, there's more scrutiny over purchasing decisions. If I'm on a business trip and I go have that $50 steak dinner, there's probably 2 people approving my expense report than what's happening on the infrastructure side or cloud and software engineering side. I could spend $50,000 with a line of code. I could spend $1 million with a line of code, and there'll be very little oversight of that. And it's not because we don't want to necessarily try, it's that it's very hard to get the feedback loop going and flowing to get the right feedback to the right people at the right time. But whether that's happening or not, the reality is this: every engineering decision is a buying decision. And we're operating in many ways, however, in this realm of reality. Works fine for me in development. Everything's perfect. I deploy it. It's finance's problem now, right? And that's not the world that we want to be operating in. In fact, the economics of the companies that we work for, engineers have the opportunity to turn their organizations into some of the most profitable companies in the world by making some of these better buying decisions. Now, I'd be remiss if I didn't mention that like AI is coming, and oh, by the way, it's probably going to cost you a lot as well. Now, Sam Altman didn't say this, but he certainly talked a lot about how much this stuff costs. It's been on everyone's top of mind. I'll leave you with one thing to look up later in your own time. Go read about Jevons paradox. It's all built around this idea that the more efficient you make something, the more of it you consume. And we see cost as a driver of innovation, not something that slows down the pace of innovation. Take, for example, DeepSeek. Now, we can argue about how much it costs to actually construct or whatever, but the general consensus is it was cheaper, and that was driven by a desire to innovate and move. And so organizations that embrace these ideas, engineering decisions or buying decision, that cost can be a positive force for innovation, well, actually, maybe we'll get around to not having it cost us a lot and instead see it as an investment that pays us back. And by the way, there's lots of naysayers here. The jury is still out. This fine gentleman here is pretty convinced the cloud was a mistake. And he's been talking quite a lot about it. A lot of people have been talking about this. it would break my heart if the cloud was a mistake. And I happen to think that he's wrong, but there's a but. I think that the move to the cloud actually isn't going to necessarily happen in our lifetime unless it makes strong economic sense. And as I told the first team that I ever worked with building cloud systems, I said, if we all want to play with the toys, we're going to have to figure out how to make this work with the budget. And when we use that as a motivating factor, we actually ended up coming in under the budget and achieving margins that exceeded 99% in some of the projects that we were working on. It drove innovation like you wouldn't imagine. It drove the rest of the organization that I was at to start adopting cloud faster than they would have otherwise. But it broke down when we didn't expand this notion of every engineering decision being a buying decision to the rest of the organization. So that's the kind of broad strokes that I want everyone to have in their mind as we kind of go into this conversation, because I've spent time with the numbers. I am a little bit of a madman. I do believe very strongly that it makes economic sense, but we're going to have to do something different in terms of how we're building software and how we're constructing systems. And there's somebody who should know a little bit more about this than I do, who's been talking about the frugal architect. So Werner, CTO of AWS, Dr. Werner Vogels, talked about the frugal architect and these laws of building cost-effective systems. And the most important one to me is really number one, something that has been near and dear to my heart, which is that we should treat cost as a non-functional requirement, that we should use it to drive innovation. And that becomes part of the design process. Think about how we can get out of the reactive mode to the proactive mode. And so he put up this website, The Frugal Architect. If you haven't seen it, you should go check it out. There's a ton of great ideas and things that we should incorporate into our engineering processes. And again, this all comes down to how we think about the engineer's role in software profitability. I don't want to think it in terms of cost. Nobody necessarily gets out of bed in the morning to go save money or cut the cloud bill. They get out of bed in the morning to build cool stuff, to innovate, to design, to grow. And I see a really tight coupling between cost efficiency and system quality. A well-architected system is a cost-effective one. But the question is, well, how do we start thinking differently about this? And that brings me back to $1 million line of code. So I wanted to, just for the conversation today, share one example of $1 million line of code. Just to give us something to think about as we have the conversation and get into the details. But it's one of my favorite examples, and I pulled it out of some of the stuff that I blogged about and spoke about in the past, and it's a pretty good one. So you don't have to be developers. This is a bunch of Python. It doesn't matter. The reality is many people, even the folks who wrote this code, when they look at it, developers themselves are like, I don't know, I wrote that years ago. I don't even know what it means. It's hard. It's hard to understand if this is perfect or there's a problem or where to even start. But what you're looking at in front of you, there is $1 million being spent with the code in front of you. That's really hard to visualize as well. And if I asked you to identify exactly where that $1 million is being spent on this chart, even if you came and asked me to see it, I don't know if it would pop out at me immediately either, because I have to have a little bit of context. So if I get into the details, there's actually a couple things happening here. Somebody well-intentioned at some point decided to add a timestamp to the data. The original engineer who built this, thinking about kind of the limitations of DynamoDB and how things work, probably got everything running perfectly. And then someone, maybe it was an intern, maybe it was a different team, added a timestamp. Pretty small, innocuous change. What they didn't realize is that by adding that timestamp, they actually pushed the size of the data that was being written to DynamoDB over the 1024 byte limit, just by 17 bytes, And that instantly made the right cost of the system double. So the interesting thing is this was already in this environment costing about $500,000, and now it's costing $1 million. Just from adding a very small piece. Now, what was the fix? To cut that out almost immediately and make this ultimately scale better over time. Shorten the word timestamp to TS. Write a format that was much more compact in terms of the time string. And now I'm magically under the byte limit. Just a few bytes. That's the part that is so, I think, fascinating to me, is this is 2 bytes away from costing double what it cost before I had made this change. And that's how important some of this broader systems thinking is. Now, the natural question you're thinking is, well, how would I go about observing this? How would I go about making sure that I get ahead of this and not make this mistake or identify these things in the first place? And this is very much like the Schrodinger's cat kind of problem, right? I like to think of it as that costs, when unobserved, you could think of are either super expensive or super cheap, but you don't know. Well, and to take the analogy further, I think the reality is that it exists in both states simultaneously, and therefore it is super expensive until you are observing it. And this is what I mean about bringing cost in as a non-functional requirement. You are incorporating that in your design thinking, which means as you build, as you iterate, it is just one of the many metrics that any engineer should be thinking about. Before, it costs this much. After, it costs that much. And the tools and the technology exist to identify these things. It was one of the problems that I set out to solve just a little bit over 9 years ago when I started CloudZero. How do I get this data to the developers so that they can use this to make decisions in a timeline that's relevant? And the reason this is so important in the broader sense is what I call the cloud innovator's dilemma, right? Today, many of us are operating in this up and down cycle where we're building, we're innovating, we're creating, we're doing all kinds of cool stuff. And then suddenly somebody runs in the room, probably from finance, and starts yelling at people. And then we halt what we're doing, and we have this period of what I call the trough of lost innovation, where we're trying to get our arms around the problem. We're trying to correct mistakes that might have been made. People are uncomfortable with this period of time. But the real challenge is the business is losing momentum. The business is losing the opportunity to grow. Because if you're building well-architected, elastic, cloud-based systems, I have some bad news or good news for you. Over time, your cloud bill is going to go up if your business is growing. Because if you've built an elastic auto-scaling system, of course it should. But it also should go down automatically in conjunction with your business, so that something that connects these two worlds, finance and engineering, can emerge as the most important metric. By the way, AI is right there, and it's coming. This innovation halt that is going to affect us very soon. So the last kind of piece I want to leave everyone here is how to think differently about this and how to use certain types of metrics to get ahead of these million-dollar lines of code. Today, we might be looking at how much money we're spending on EC2. This is an interesting but unhelpful number in our environment. What I want to shift your thinking to is thinking about the unit cost of what it is that we do. What does it cost as a company to do the thing that it is that we do? It's not really interesting to think about $25 million spent on EC2. But if I can break that down to 25 cents per transaction, and I happen to know that my organization charges $10 per transaction, this number is no longer scary. And this can inform where in my code I should be looking if I'm looking at a transactional level or a component level and understand the unit costs of those parts of my system and how that filters into my overall unit economics of the software I'm building. That's where these things start to pop out immediately. Because that DynamoDB example I gave you earlier, anyone want to hazard a guess like how much that cost during development? It was probably a few dollars, and maybe $10 after testing. nobody would have noticed. But once deployed to production and under load and scaling, it became very expensive. However, if I look at it on a unit cost level, it would have stuck out like a sore thumb. I'm spending $20 per transaction. I happen to know we're going to sell things for $10 a transaction. I got to fix that. I got to fix that before I go to production. So the thought I want to leave you with before we jump into the conversation is leverage unit economics as the bridge between finance and engineering. If you're an engineer and you don't speak finance, it's not a problem. The interesting thing about finance and engineering is they are both highly specialized, expert level organizations that both happen to just speak completely different foreign languages, right? Your CFO doesn't want to hear about Kubernetes. But if you can show up to that meeting and say, hey, we need to modernize some of these systems because the unit metrics of that system are putting us out of business. And if we do this work, I'm going to increase the margins overall of our business and put money into our pocket. I promise you, whatever technology initiative you're trying to pursue, they're going to sign off on it. Okay. So if you remember one thing, remember that every engineering decision is a buying decision. But let's get into the conversation. I'd love to hear what my panelists thought about this and where we should get into the weeds.
Well, unfortunately, Eric, the problem is that we're not going to have much disagreeable conversation on this one because there is so many things we agree on. But I want to develop one of the points that you made, and that's around, cost as a non-functional requirement. And you alluded to it towards the back end, but I think it really needs taking out. It's not just cost; it's also value as a non-functional requirement. So this is why I actually disagree with Werner Vogel's. Value is a valid metric. And the reason why I say that is many organizations, take for example, retail organizations will have loss leaders. And those loss leaders are the things that feed and drive the business. And as a result, and let's bring this to life actually. I worked with a parcel delivery company where their app that people use is a loss leader. It makes no money. But what it does do is it enables people, their user experience to be better than the competition. As a result, they'll send more parcels with them. The question, therefore, is the value of that loss leader, the cost that's being incurred, still being valuable as a loss leader to the business? It's okay that we're spending money as a business development factor, and we're making no money from it. But at what point does it become too expensive for it to be the case? So this is why this obsession that occurs in many organizations around cost also doesn't help, because we're not actually, but we talk about speaking the language of finance, and that is important, but we've also got to speak the language of business. And
Jez, I love that. The value is the important thing. Like, why are we doing this in the first place? And this is why I often kind of get folks to think about unit economics in a little bit more detail, because most organizations, sometimes they go, oh yeah, I got that. I'm taking the total amount of my cloud spend, dividing it by the total number of customers I have, and I've got the calculation, I'm done, right? And I'm like, well, wait a second. What are your most expensive products or features? Who are your most expensive customers? Are you breaking it out enough? Because you want to understand what are those loss leaders, where you might be subsidizing, where some features might be subsidizing other features in terms of value, right? And you might see that really amazing pattern where, all the value is being driven by this thing, but you don't get any business unless you have this loss leader that pulls people in, right?
Absolutely.
And I've seen customers of ours start down this road and then discover, wait a second, we have this thing over here sitting in the corner that's actually pulling all of this value out of the air. And we don't actually have to do a lot of work. Actually, it turns out our engineering team's pretty good. We've done a great job. We're just running this product that nobody's using and costs a lot of money. We should just turn it off.
Yeah. So, but I almost going to come back with another challenge as well, because and I noticed that Henk in the chat has alluded to this. I'm going to ask you this question, both to you, Victor, and Erik. As engineers, as technical people, at what stage in your professional development did someone sit down and say, hey, Erik, Victor, this is a P&L, this is a budget, and when you do this, this is what happens. But what stage in your career did that start to happen?
The only time it started to happen in my career was when I was in trouble. I was in the principal's office, right? I was called into the CFO's office to explain why we just spent, $300,000 on a surprise, right? Yeah. And I was like, well, so we had some bugs, we had some things, like there was this, they were testing that. It's like, hold on, do you understand the effect that this has on the business? And I was like, let's talk about it, right? And I got taken to school, let me tell you.
Yeah.
Right?
And unfortunately, that's how most people learn. And often they're in senior roles when that happens. And that's not cool. It's not a great way to learn. I mean, learning from mistakes is always good, right? Fail fast, all of those sort of things. But to learn in that type of failure environment actually is not a great learning experience.
It was that Bill panic mode, because after that meeting, I came back and we're like, all right, we got to do something different. We got to slow down. We got to fix stuff. We got to, like, whatever it is, right?
Yeah.
And it is not, most people are not comfortable with that kind of conversation. Some people feel like, oh, I'm going to lose my job. What's going to happen? I took it as a challenge. I kind of said, all right, challenge accepted. How can we turn this into a driver for innovation and adoption? But it is a really hard thing to do. And you're right. I think we're not bringing enough of this knowledge down to the individuals who are writing the code.
Yeah. So I mean, the challenge was to bring some actionable insights to this. And so here's my first bit of actual insight to every person who's on this who's either watching this on record or watching it live. If you are a dev team or sitting in a dev team, or you're an SRE, go to your product manager and get them to sit down with the team and explain the mechanics of this to you. I guarantee you that will be some of the best time you spend on learning this year, if not your career, because it's game changing. It changes your attitude to the way in which you do things. Not in a massive way. We're not talking about how you're going to suddenly wake up in the morning and be a financial whiz and be the next genius, but it will change just a few things about your approach, which, as everyone knows, it is these infinitesimally small changes that aggregate up to such a massive effect. And when you do that, this is a career-changing moment for you. You will become one of the rock stars. You absolutely will.
These are the engineers who get promoted, right? Yeah. These are the folks who up-level their impact on the organization. I've seen that time and time again. That is absolutely the way to get, get recognized by the business. I mean, where it ended with me was I found myself eventually presenting to the board and talking about things that we're doing, and the exposure I got in the organization. And that led to eventually me going out and founding CloudZero, because I had learned so much of that experience. And it is so powerful when you get people thinking about the economics of this. I go back to, I studied computer science. I wish I would have studied economics, right? Because it's at the core of everything. Now I'm a student of economics, right? It is everything that ultimately drives that. You're so right.
This is what we have in common, right? So my first career is I used to professionally re-architect the world by blowing things up in tanks. I then left and started technology. It was only until I was working in a consulting firm and a particular software vendor, who I'm not going to mention, was talking about cloud and said the only thing was OpEx. That's the only way you could ever treat any of the costs in cloud. And I was working in a consulting organization at the time that had a few accountants kicking around. I was like, most of my clients are really CapEx heavy. This doesn't work. And then I discovered economics. And suddenly, when you get into economics, and again, devs, SREs of the world, just get into a little bit of economics. You'll start seeing the patterns of behavior, of human behavior of the world. Because code, software engineering, fundamentally, we are also talking about that user experience. You are talking about behavioral patterns, but the things that you're creating do shape the way how people behave. That's another non-functional requirement to bring in when you shift left in your thinking. And when we talk about getting with that product manager to teach about finance and talk about user experience and those sort of things, That's your shift left moment. That is the moment where you've got to go click. It really does change your life.
Yeah, and it's and from the engineering perspective, it's also super interesting to ask, and I also suggest everyone to ask, like, can you explain me the cost structure of the project that we are having right now, like how much the architecture that what we are doing is costing? Because I did that exercise and I was like, okay, I found out that, for example, already this instance was one of the major cost drivers because it was there all the time and we couldn't shut it off because how the architecture was there. So as an engineering, it's a very interesting, if you are into, the bits and pieces of the architecture, knowing what's driving which cost. It's an engineering exercise. You can see that it's only related, instead of CPU percentage or whatever, you are relating it to a cost. And why, and explaining why that cost, then you can see the complexity of how the cost in the cloud could be. And you learn a lot, and you would become like this FinOps engineering role that is optimizing for both performance, but also knows another metric that you focus on CPU, memory usage, but also on cost, because that's a driver. What's the election of what you do? Like, where do you put that instance, or do you shut it down? Do you keep it up? Is it efficient in terms of human resources? Because this is another conversation as well. Like, the effort that you put to optimize these workloads need to compensate the actual cost. If you are doing like optimization for $100 a month project, maybe it's not worth it because your hour rate is higher than that.
That's a lovely bridge to the second thing I was going to come to from the thing that Erik was talking about, right? So on the slides, it says, don't be afraid of finance. They're as equally afraid of you, right? It's true, right? We've got people who speak two different languages, right? So it's about finding that common ground. Now, I'm going to say something controversial. I should not have the job that I have. FinOps should not exist. Because if everybody did the well-architected framework, if everyone had cost and value as part of the disciplines of non-functional requirements at the earliest stage, FinOps would never exist, because people would stay on top of their code, they'll stay on top of their deployments, and all of that good stuff, right? But it does, because humans. Now, also finance folk, right? Once upon a time, where they got the technology bill, it was 11 lines long. They could go, that's OpEx, that's CapEx, right? Good, easy, move on, and I could go about my life. Now we're talking about bills that are millions of lines long, full of mumbo jumbo. They have not got the first clue what they're looking at. We've got to help them understand that. And this is why things like Focus exist, in order to start breaking out the bill into more standardized ways and more consumable ways. I don't think Focus goes far enough yet. And when I get the opportunity, I want to be able to do it. I'm actually putting some of that into financial language as well, so our finance people can really understand that breakdown of the cost structure of the bill. But this is the key point. When you have those conversations with finance, they're the ones who are really going to show and shape your thinking about that value conversation. Because if you give them a number, they're going to ask you to give you another number to give them context, right? They will always challenge on that level. Yeah. They say, well, we're spending $1 million. Okay.
Versus what?
Versus what? Are we making $50 million revenue? Well, in that case, it's loss on the rounding, and I don't care. Or we're spending $1 million, but we're only earning $1.2 million. Well, okay, that's okay. Was that deliberate? Is that part of the model? Have we modeled that? So that's about what we're talking about here. We've got to turn around and look at give context to things. We live in a world where people are trying to seek binary answers to everything in life, not just in what we do. Look for context. With the context comes the wisdom, and with the wisdom comes the decision making that matters.
That's deep. I mean, context is everything. And I sometimes people ask me, why don't I just manage all this with some of the things that I'm getting from my cloud provider, or I'm just trying to, and I think it's tied to something, which is no one should be thinking about what they're spending in terms of the infrastructure as their cloud provider would define it, because it's not important to your business, right? If you're a company that delivers meals, I want to understand what it costs to deliver a meal. If I and I want to understand what services feed that process so that I can understand the importance of those services. I need to understand the context of this in the terms of the business. I need to tie it back to the teams that are responsible for those features. If I just say I'm spending a lot on S3 and EC2 and the millions of lines in the bill, it means absolutely nothing to everyone. It should mean nothing to everyone, right? But if I can get in there and get that context to understand, well, wait a second, I do this, we do this, it costs this, and we're making this. Now you have the basis of like an actual, hey, we have a functioning business. we have something that's pretty good. Or you can start to realize, wow, if I can just change this one little detail, our margins could be unbelievable.
Yeah.
And cool thing is you'll almost certainly end up with a faster, more effective, more delightful product for your customers and for everyone else who's using it. The cost figure, if you just ignore for a moment that it has a dollar sign in front of it, or you ignore that and you go, it's just a number. Bigger is bad, smaller is good. Okay, it's just a number, and I want to figure out how that relates to the effectiveness of what I've built. I think of nothing is of a greater objective if you're an engineer than to be confident that you're building really well architected systems, right? And you can use that as an input, but you got to have that context. It was one of the first things that we focused on at CloudZero, which was this observation that most organizations are not allocating and attributing the majority of their spend effectively. They're relying on tags. Tags are a disaster. Maybe on average, something around 60 to 65% of all of my spend is getting correctly allocated in the first place. And it's all getting allocated to things that engineers like, not things that the business needs. And we're like, no, let's create this common language between these two worlds. We work as an organization to deliver meals. How much does it cost to deliver a meal? What features support that? Well, there's the delivery service, and there's the phone service, and there's the whatever. Okay, cool. And which teams are responsible for those? Okay, great. And which of those are the most expensive? Well, that piece is, all right, let's focus our energy there.
Yeah. And then sometimes you go, well, it might be the most expensive, but actually that's not the one where the biggest burn was, as in terms of inefficiency. And this comes back, and again, this loops back into your deck, Erik. It's about using the correct tools correctly. When we talk about, so I'm yet to be convinced by Henrik that the reason why they went back to a private cloud setting was had they fully done their transformation to take people on the journey to skill, could they skill up, and retain those skills? So I have no doubt that they invested and they trained people up, but could they retain those people because they're hot demand? Were they using the correct tools correctly? There's so many questions that come out.
I have so many questions, and when I've looked at the data that is out there, I have even more questions.
Me too.
And I see anything that has a fixed cost as one of the most dangerous things in the world, because it means that it's over provisioned and a disaster is looming.
which is not cloud.
Which is not cloud,
right? You are treating it as
a
data center. You are treating it as something that you are going to amortize, and you are over provisioning to later scale, but you are not making it dynamic, and that's super problematic.
For the record, I'm not suggesting that 37 Signals did use it like a data center. I'm not suggesting that. But what I'm not clear on is, really, how far did we really go on the cloud journey to optimize stuff and really question the value of what we were deploying where before we pulled that plug, and then told the world it was terrible. Just so people know, right? Cloud repatriation, yes, is a thing. Do you know how much money was spent on cloud repatriation last year?
Oh, I wish I knew this number. I have a feeling I'm about to learn. I love it.
It was a couple of billion.
Yeah.
How much money was spent on public cloud and SaaS last year globally?
That one, it's
$600 billion. In 2027, it's forecast to be 1.12 trillion.
Yeah, if you include SaaS in there, it is pushing past $1 trillion very soon. And So that is a drop in the bucket, right?
Yeah, so it's good marketing hype, it's good story, but actually we've still got the cloud waste problem because we've all got more to learn. And for the record, everybody, there's not a day when I'm not learning something new. There's more stuff every single day. I'm not like, well, I didn't know that. But then also what I didn't know is now wrong, right? So things that once were things where we were pretty baked into the way how FinOps and cloud work. Now that the world has moved, it's shifted. So this is the whole time to keep learning, but sometimes just take different perspectives on it about the way how we're looking and we're learning.
You've got to stay humble. Literally everything is new every day, and AI is making it go even faster. Right now, I have so many folks coming to me trying to understand the cost of these experiments, these costs of these AI features, and they're realizing that unit economics is even more critical to this process, because they're launching these features and then discovering that they may have made a horrible mistake. Because that feature is very expensive, because customers love these features. They're adopting them at like lightning pace, but it costs money. It costs a lot of money sometimes.
Playtime is over for AI.
Yeah.
Right? Playtime is over.
Yes, yes, to bring this into connection, because I'm going to start opening the Q&A part, because there is a question that is perfectly to this. So people, feel free to add questions on the Q&A section or the chat. We will try to answer all of them. So there is an anonymous question that as an engineer, they say the unit economics is not fully visible, or connecting engineering tasks to the business transaction is difficult. And I can relate on this. So they ask about like, how do we bridge this, or how, you as an engineer, how do you get this information, or how you are able to bridge to the sources? Erik, maybe, and then I can ask. Yes.
Okay, go ahead, Erik, please.
Yeah, so I think it gets back to this, something actually, Jez, you said earlier about, you can't just have a number. It's that versus what, or over what, or, compared to something. And that is exactly where I think you need to start thinking and put your mind as an engineer. Is if I'm looking at that number and I see that this feature I own costs X, well, I need to figure out how I'm going to divide that by something to start understanding it. And that division isn't as complicated as you might think. It can start as simple as taking the data you already have. If I have a web server, I have a transaction log. If I have a database, I have a SQL query log. If I have some system running today, an AI system, I have information telling me how many inferences I'm doing an hour, or how many tokens I'm consuming per minute. I have a consumption. I have a figure of consumption, right? And if you can bring that number as close as you can to the demand drivers of your business, the more power to you. But I don't want people to try to make perfect be the enemy of get started somewhere, please, right?
Yeah.
And a lot of times, if you just take the query logs of your database, because for most people, they might have the most expensive thing in their environment might be that big giant database cluster sitting in the corner that everything talks to, right? And they're trying to understand how to break that apart, and they're going, well, tags isn't solving this problem. It's never going to solve the problem. Take the query log, divide that against the cost. And if you can do that down to the hour, now you can start to see what forces are actually driving those costs. And it becomes super powerful for the engineer to now go, oh, I know that code that kicks off every night at like 3 a.m. in the morning. That's the thing that's causing all this cost in the database. Oh my gosh, right? They have all this rich context. And obviously, we set out to make this simple. We created two very simple ways of bringing data into CloudZero's platform. One was very open API for bringing any telemetry in, and doing the thing that everybody was already doing, which is bringing in tens of cost data. But we made that division very simple, down to the hourly granularity. So I can drill all the way down. I can start with this is my company. These are my features. These are my services. This is my database. This is how it breaks up by query, right? And just by bringing those two sources of information, and the math isn't hard, but it will be a lot of data. So we've built a very purpose-built data platform to do that analysis, but it's start with what you have, and then you start to see the power of that. You start to share that with other people, and the rest of the data will come out of the woodwork. It really does.
So this is the bit where I'm going to disagree with you, Erik.
Oh, I love it.
Oh.
Okay, so if you, as a lowly engineer, junior dev, or in a dev team, want to know about understanding how much things cost and how this thing works, you're going to have to do one of the most uncomfortable things in the world that people don't like to do. You're going to get out your seat. You're going to walk up to somebody, a senior engineer, or a product leader, product team member, put your hand out, grasp it, and say, "Hi, I'm Jez. I work in this team. Can I grab a cup of coffee with you and learn about this, please?"
Yes.
Right? And this goes back to being that humble thing, right? The amount of times I've actually had to get teams of engineers to actually stop what they're doing, literally turn their desks, their chairs around, and then just say, "Put your hand out and shake that person's hand."
Yeah.
And introduce yourself to them. Make a human connection, right? This stuff doesn't happen by Slack or Teams or what your messaging thing of choice. This is about humans and coffee, right? Or whatever, or even take them to the pub and that sort of stuff. So Erik's given you really good advice about what to have in your back pocket to give you that context and that data to have that conversation when you've formed a common understanding with that person.
Yeah.
But the first thing you do is get out your chair and go and talk to people. So respectfully, I disagree about the first step.
You have to have that conversation, because you might discover that like something you care deeply about actually in the grand scheme of things is not as important as other components or other systems. And it's not to say that anything is that you're working on isn't important, but there are a lot of dynamics here, and people should use that opportunity to get out there and talk, whether they're talking to someone more senior on the team, or God forbid they're trying to talk to the product manager or the product lead, or even some part of the business. It's better to have that conversation and build a relationship before you get pulled into the principal's office like I was many, many years ago, right? It would have been so much more.
This is the way how it accelerates your career, right? By those relationships where if you're a known person in the business who understands not just the technology, but understands how the business works, you start growing this wonderful thing at the top of your head and start being called a unicorn, right? Because those just don't exist, right? People don't tend to do that, right? So you'll make yourself into a unicorn by doing that.
Yeah.
The other thing, I mean, you can tell that I'm all right. So full disclosure, right? I'm not an engineer by heart, right? That's not my thing. I'm much more about the finance, the management, part of this game, and I'm really interested in behavioral economics and behavioral science. And I'm going to go deep on you again, guys. So younger developers live in a world of where they've had more and more social isolation. People have gone through the COVID period and all that sort of stuff. Forming relationships and having human interaction conversations is an actual skill that people have either forgotten or have never had the opportunity to learn properly. Again, you want to make a differentiation in your career, learn that skill. It will completely evolve. If you think about it, who are the people who make all the big decisions, and what age group and generation do they come from? One where we used to go running around of where you rang 3 times on the telephone, the landline, and then you put the phone down, and then your mum knew you were safe coming home. So you didn't have to pay the 10p for the telephone, the public telephone. Stuff like that, right?
Right.
The way in which they communicate is different. And that involves human interaction. You want to make that difference? Speak their language, right? Speak in a way they can understand and engage with.
We all learn when we step outside of our comfort zone, and we definitely got to step outside of our comfort zone on some of these things. But it'll be so powerful to think differently about this, and I think it ties back to a couple of different things. One thing that I find fascinating is that we have made it this far in our cloud journey, and not collectively as an organization or world or community, like really understood the fact that the entire equation for how we think about efficiency has completely flipped on its head. In a data center, I was given 10 boxes, and Efficiency was, did I use 100% of what I was given? Right? And that's a much different kind of equation. I have to fit inside this box. I need to consume everything that I've been given. Otherwise, I'm squandering the resources that the company has given to me. And for decades, we all operated in that kind of mentality. I've been given these resources, I should use them. Suddenly, we now live in an environment where it's practically infinite scale. And the problem is now unbounded. It's actually very hard because very few people have developed any skill. In fact, it's not even, if you get to the behavioral, where you got me thinking is when you said behavioral, because as the human race is not built to think about the minimum consumption. We tend to try to consume all that is available to us, unfortunately.
It's built into you. Why? Because
built into our DNA. Yeah. And now we're operating in an environment where I have near infinite scale. And it is my natural inclination to go, well, I can just get more. I can just get more. I can just put more into this system. We have to flip that on.
The analogy I use for this, by the way, is it's like being a 6-year-old and putting them in a candy store and saying, go on a diet.
Exactly. Like, what did we expect that was going to happen? Of course, right? But if we can flip this on its head and go, you know what? This is actually a new kind of problem that is going to allow you as an individual to level up and distinguish yourself, because you're solving now a much more interesting problem, and one that might actually impact everything in the world. It could impact the very planet because we're not consuming more than we need to consume. Is how we think about using the least amount of resources to accomplish the task versus everything that's available to me. Because I've looked around, I may have infinite scale, but I still have not figured out how to have infinite wallet.
Yeah. I think everyone here is trying to do that.
I don't think anyone will disagree with you about the desire for an infinite wallet, right? So, but and just building on that, this goes back to the code point. Code is not just science; it's art, because simplicity, cleanness in code drives efficiency. Yeah. And by the way, just for the record, simplicity is really hard to get.
Right? It is one of the hardest things to do. One of my favorite quotes of all time was from Pascal, who said in French, but I can't say it in French. He said it translated, "I'm sorry that I wrote so much. I didn't have enough time to make it shorter."
Yeah, absolutely.
It's and it's because it's hard, right? It's hard to get that down to, but it is, when you've accomplished something like that, it's amazing. And the other, element of building systems is it is a process of constraints, and this is where I borrow sometimes things from manufacturing, lean manufacturing, and, concepts around Kaizen and things like that, where we have this whole concept around the theory of constraints that drive innovation. You take the most constrained element in your environment, you focus on it, and it drives innovation for the whole system. Yeah. And that's exactly what the opportunity is in front of us when we think about how are we going to improve our business. The engineers looking at this can go find that constraint in the system and optimize it, and it will drive efficiency in the whole system. And it just focuses people. It gives them the focus and the vision. But we got to go communicate. We got to go talk. We got to go learn. We got to go share all these things. But we have to step outside of our comfort zone and realize, yeah, this is an entirely new world. Some people still don't think clearly about OpEx versus CapEx.
Well, so let's be honest. Some people don't even know the difference between the two, and that's going to help. But just go back to your point. Mariano's asked a really good question about talking about monoliths. Sounds like log scrapping is a good strategy for cost allocation. Yes, I would also go further than that. Log scrapping in general is a good thing for your cost efficiency. Why do people log? Log what you need to log, not log everything. You don't need to log and log. But also the things that you log, how long do you actually need to retain it before you can get rid of it? Truly.
Yeah.
Is it 90 days? Really? Is it 30? Is it a week? Or is
Well,
it
I should have included one of my other favorite examples of $1 million lines of code, which is the debug statement.
Yeah, that's probably going to be like one of the most generators of all the companies.
Most nefarious ones, right? You know, you even have maybe an ops person or somebody who's outside of the development process going in there and saying, well, I don't know how it's working right now. Let me just turn on debug logging. I'll just set the log level to debug. And then they go away for a long weekend. And you know, in the meantime, like 5 terabytes of data have been written to CloudWatch, and that bill comes due, right? And you don't need that information. I challenge my teams always to, you know, if you're going to save some data, think about when you can get rid of that data, right?
Yeah,
it cannot hang around forever. It's a dangerous thing.
And then put a tag on it to say when you're going to delete it. you know,
yeah.
and you know, so it pops up and reminds. Absolutely. So this is all about cultural mentality and culture and mindset. If you can build that culture into your team, where you know you can charge, and you can gamify this, peeps, right? You can gamify about who's got rid of the most, who's got the highest efficiency on logs, or whatever it may be. There's lots of different metrics you can use out there, and I'm going to give a nice opening for Erik to start talking about cloud efficiency rates in a minute. I use a slightly different version of that because I also then bring in some of the value parts into what he talks about. But it's all essentially the same thing. It's not the case as to whether a workload is expensive or not, or whether your code is expensive or not. It is how efficient it is in terms of the context of the business.
Efficiency is the most important metric, and it can be as simple as something like the cloud efficiency rate that we talk about. Cost minus revenue over revenue. Like it's not a hard thing to calculate, but you get at something that can benchmark you versus other folks. And the other important thing about any sort of metric is there are different phases in your development process where it's okay to have numbers that might not be perfect because otherwise
it's a process.
It's premature. It's a process. In the early stages of building something, I'm just trying to answer the question, can I even do it? Can it even be done? Right? I need to figure that out first before I go and try to make it more efficient. But efficiency, not cost. You're speaking my language, Jez. Like that's
and that's why you don't put massive amounts of reserved instances and savings plans on non-production environments.
Yeah.
You know what the biggest saving you can make? Forgetting spot instances, but actually just in the way how you manage stuff.
Yeah, shut them off.
How many? What's 24 times 7? 168. What's 12 times 5? 60. That is a 68% reduction efficiency by doing no engineering effort other than going and turning it off when you finish the day, and you turn it off at the weekends. Right?
I think that one is one of the major. I think when I was reading the book from Alfonso, the Efficient Cloud FinOps book, like they do the exercise and they go process by process, like a real use case when you have 24/7 EC2 instances fully provisioned every day, and like the highest ROI was shut them down at night, and it's like instead of 24/7, it's like 8. That .5, and it's like 40 because it's what you need for testing, and it depends because, for example, I can have the experience of time zone difference complicates that, or things and that.
But that's
also,
okay. Because then it's being used. Right? It's being used for value, right? There's a purpose in it. I mean, ultimate discipline is you fire stuff up, you work on it, and then you shut it down. That's ultimate efficiency. But let's be pragmatic and honest here, right? Yeah. It's never going to be that way across everything.
Well, I'm obviously an optimist in many ways because it's difficult to see this coming true yet. But I feel like if you are creating things without an understanding of how it scales up and down, I see so many environments where all the energy has been put into scaling up and very little energy has been put into scaling down. And I think it should be in many ways, the cloud providers could have solved this problem by making it impossible to create something without also defining how it will come down, right?
Yeah, but capitalism.
Yeah. Because everything should go up and down based on demand. I subscribe to that world, and the only way you get there is if you think about how you design your systems to take advantage of this elasticity and this auto scaling capability in the cloud, to use things like spot instances and to use different types of compute and to think differently about how you built your systems. But so much of what we've done is done lift and shift, which I think lift and shift is the greatest lie ever told in the cloud, unfortunately. But it's been wildly profitable for me.
So again, I'm going to disagree agreeably with you. Is there is a place for lift and shift, and that's when there is a compelling business driver. But with that needs to come a plan that says,
right,
we are going to get the hell out of it. We are trading cost for a different business value factor, namely it could be a compliance thing, a risk thing, lots of different reasons.
Yes.
There is value in doing it, but the moment you do it, the clock is running, and the value is decreasing every second.
Yeah. That is what's missing so often. We had to get in the cloud because we wanted to get in the cloud. Okay, well, what was the plan, right?
Yeah, absolutely.
Yeah. They migrate for the scale. They don't think about like, what's going to cost us, and like, this is a question that we will answer after we will migrate to cloud, instead of taking, which is a point that is very valid as well, like making the cost analysis a part of the migration or the re-architecture of the workload, because some people like migrate and they say, we have a Kubernetes cluster in this data center, we are going to put it in the cloud and it's going to be the same, it's going to consume the same. It's like, it doesn't work that way, and you can make it way more efficient with, I don't know, ephemeral environments and super much more efficient things and spot instances and blah blah blah, and the cost is going to be way less. And I wanted to highlight another question that was over here that they mentioned. Well, it's about the presentation that they were asking about the metric. If will the metric EC2 hourly help, because they have the cost per transaction cost doesn't apply to organization in all the domains. Like if you don't have like the cost per transaction, and you have EC2, let's say, metrics, how would you measure that? I would say, and I can say my opinion and then you can go, Erik, is that you need to have some kind of value metric to reference your cost because otherwise, why are you running a business? Like all businesses have a value metric. So you need to reference.
The way I think about it is if you're coming up with a unit metric that doesn't make any sense to a business person, you're probably picking a metric that might be interesting but not useful, right?
Yeah.
And because it should be tied to the demand drivers of your business. It should be tied to the value that you're delivering, because then that can help you really understand if you're spending your time in the right place. It's interesting to understand like my cost per vCPU hour, maybe, right? But only when I use that metric as the input to some other equation. I've seen people use that effectively to understand how that change in code is going to push up their CPU consumption, which is going to push up their overall consumption of EC2, which is going to have a overall effect on the unit cost per API transactions. So that data flowed into another transaction that was now tied to business value, right?
Yeah. You need to tie to business, like, because for example, or what I see, or my vision from this, like the career that I had, is like at the beginning, especially engineers or tech people, we focus a lot on like the features, making the best code, making the most complex things, making the most crazy feature in terms of the most challenging engineering task. And we forget
that's cool and should be done, right? Doing funky, crazy stuff that no one's thought of before.
But you need to think what's going to imply this for the business. Is this going to be a driver that will make the business greater, or will make this feature better, or will this make my business a better company? Not doing the task because it's challenging. You need to make a challenge that will imply I don't know, you are sending a rocket to the moon. It's a challenging thing, but the result could be amazing for the whole humanity. So you need to think about, okay, what's the output? Is this complexity because I want to do a crazy thing, or I want to do a crazy thing because the output will be improving our company like to a level, or having a result that no one has seen and is impacting the business. The idea is that engineers, for us, we need to think more about like impacting the business, like instead of ourselves, impacting what the business is doing and impacting and making the company or what you're doing better.
I mean, let's be honest, guys. Right, no one wakes up in the morning and goes, "Oh, I'm going to screw things up today." Right, no one's doing
no
that.
one.
Right, the road to hell is paved with the bricks of good intentions. So, what happens is that we go down a route, and sometimes we don't pause and think and consider, what are the implications wider than just someone screaming at me to ship code? Sometimes we've got to turn around and say, whoa, what is the effect we're trying to achieve here? Because I might be able to do this in a quicker way. I might even have some stuff in the locker. Because going and looping this all the way back right to the very beginning about what's the question, $1 million lines of code. $1 million line of code could be something that's so valuable because it's repeatable that avoids huge amounts of cost. We've got to stop obsessing about cost saving. We've also got to start thinking about avoiding costs. Can you afford not to do this?
Right. It's okay to spend $1 million if you're making 10, right? It is, that's the value conversation.
So I think we have answered a lot and we have talked a lot. So I think it's a good point to wrap it up. I would like to thank Jess for coming by, and Erik for the wonderful presentation, and you people to be in this talk. I hope it was insightful. For me, it was, and everything will be uploaded to YouTube, and you can check it again, and you can re-review it, because I think there are a lot of insights that have come into this webinar. I think it was super interesting, and the connection between finance and engineering, it's what we need to drive in FinOps, and that's what drives everything here. So Erik, yes, pleasure to have you guys here, and thanks for your insights.
Thanks for having us.
Okay, everyone, see you in the next one. Bye bye. Have a great Easter